Hi everyone, welcome back to our channel. Today we are going to solve the theoretical calculations of the transmission line parameters, which are nothing but ABCD parameters. So we need to find out these ABCD parameters. In order to do it, let us try to do the step one by one. Okay. So how to write down the ABCD parameters is we have V1 as well as we have I1, and output port voltage as V2 and minus I2. Now when you see here, we need to express V1 I1 in terms of V2 and I2. Therefore, V1 is equal to AV2 minus B into I2. Second one is I1 is equal to CV2 minus d into I2. So these are the two equations we are having. So initially to find A and C, we have to make I2 is equal to 0. When I2 is equal to 0, therefore the value of A is equal to V1 by V2. Okay. So reverse voltage gain. Next one, the value of C. C is equal to I1 by V2. So which is nothing but I1 by V2. So here it is of no units, and C is of I by V. The units will be no. And next I want find the value of B and D, then make V2 equal to 0. When V2 is equal to 0, remaining two parameters we are going to obtain as B is equal to V1 by minus I2, and D is equal to I1 divided by minus I2. Okay, so this is what we are going to get. So I1 divided by minus I2 we are going to get. So now let's try to split this problem into two halves. We'll try to implement this and later we'll try to implement this. So for the same problem, we are going to perform theoretical calculations as well as the practical calculations. Now let us try to see the theoretical calculation, which is the first step, and remaining will proceed with the practical experimentation part. So coming to the first part, we have to make I2 is equal to 0. The meaning of I2 is 0 is the I2 means output port is open circuited. Okay, so I2 you have to make 0. So I2 making 0 means, let's try to draw the circuit. So this is the circuit what we are having, and this is also 1000. This is open. Okay, so the source may be available here. As soon as I2 is 0, indirectly the voltage source, if you apply also, the current doesn't flow. So I2 into this resistor value is approximately 1000 ohm. So what is the voltage here? Voltage equal to 0 into 1000. 0 into 1000 is once again 0. Therefore this branch will act like an short circuit. You can see here, now this branch is completely short circuited. Okay, so now I'm again redrawing the network. So this is the voltage source. I have a voltage of 30 volts here with an resistor and one more resistor here, and this branch is completely shorted. The voltage what we have here will be available as plus and minus, and the resistance of this one is 1000 and the resistance of this one is 500. Okay, so now we need to find out. Okay, so as per this, we require the value of A is equal to V1 by V2, and C is equal to I1 by V2. So here what is known to us is V1 is known. Okay, so 30 divided by, and we need to find the value of V2, and I1 also we need to find out, but V2 also we need to find out. Okay, so how to find out? Let us try to see here. So V2 is the voltage across a 50 ohm resistor. So I'm going to find out V2 by using voltage division rule. Okay, so therefore V2 is equal to total source voltage. What is the total source voltage? 30. So 30 into 500 divided by the sum of resistors which are connected in series. So 1000 plus 500, which is nothing but 1500. So therefore, when you do it, you are going to get this V2 as 10 volts. So the voltage at this point is now 10 volts. The voltage at this point is 10 volts now. So you can see here, V2 we obtained as 10 volts, so which is nothing but 3, and there's no units. Why? Because this is also voltage, this is also voltage. You have to get as a gain, reverse current gain, voltage gain as 3, and we require the value of V2 is already obtained as 10, and we want only the value of I1. So how I'm assuming the I1 is, I'm assuming the I1 is flowing like this. Okay. So the general formula of I1 is equal to V by R. Okay. So what is the voltage at this point is 10. 10, the current is flowing, so therefore the leaving terminal of the voltage is plus and the current leaves, but the leaving terminal of this voltage is minus, that is nothing but high potential minus low potential divided by R. R value is how much? 1000. Okay, so when you perform this, then you are going to get the value of I1 is minus 20 milliampere. Just substitute this as I1. So here, mm, you may get doubt, sir, this is I1 you have taken. What generally I1 is? Generally, we take the network like this. We have taken the I1 and we obtained the value is minus 20 milliamperes. But whenever the I1 is flowing in this direction, then this will be opposite. So minus into minus, this is how much? 20 milliamperes. That I1 I am taking here. So this I1 is 20 milliamperes. So which will be getting as the value of C is equal to 10 to 1s, I mean 10 ones are 10 twos are 2 millimoles. Okay. So successfully we find the two parameters, A value as well as the C value, and let's try to draw the theoretical calculations how to perform for this. Okay. So now I'm drawing a tabular column. So here the first row will be theoretical calculation and second row will be practical calculation. And what we are doing initially is I2 is 0. What is the meaning of I2 is equal to 0 means? I2 is 0 is nothing but this tabular column is with output port is open circuited. Whenever it is open circuited, what are the parameters we need to find out is, so we need to find out the value of V1, and we need to find out the value of V2, or V1 is known, and we need to find the value of I1. You can see here only one I2 is 0, the remaining is V1, V2, I1. So 3 will be getting. So what is the value of V2 we are applying from the network is 30 volts. What is the V2 across the 500 ohm we obtained is 10. And what is the I1 we obtained? So when you take I1 in this direction is 20 milliamperes. Okay. So then this is the complete theoretical calculations. Okay. So when you do the experiment, you can see in another video, you'll also get similar as 29 volts, 9 volts, and 19 milliamperes, or you may get 21 milliamperes. So similar. Okay. That's how to validate your answer practically also. Okay, so this is the first step of solving the problem. Now let us try to use the second step. So successfully we find the value of A and C, and now let's try to find these two values. Okay, so I'm copying the same circuit for clarity. And now for this circuit, we need to find the values of, so for this given circuit, we need to find the calculations. Okay. So here also we are going to perform as V2 is equal to 0, and we need to find the value of B is equal to V1 by minus I2, and D is equal to I1 divided by minus I2. These two values we need to find out. Okay, so how to find? Let's try to see here. So here I2 is 0 means output port is short circuited. Okay, so we have to make this output port as short circuited. So redraw the network. So this output port is short circuited, which is nothing but V2 equal to 0, and here we are exciting this with a voltage of 30 volts, and this is of 1000 ohm, and this is of 500 ohm, and this is also of 1000. Okay, so we need to find out. So here what we are known to us is V1 is known to us. V1 is how much? 30. And from the network we have to find I2, and from the network we want to find out I1 as well as we want to find out I2. So in order to find this I2, I am marking this input port current as I1, this input port current as I2, and the current in this shunt branch as Ix, and already the voltage at this point is plus 30. This is 0 volts, and here the voltage is already 0, and this will be acting as a new node as Vx. Okay, so when you see here, so in order to find it, let's try to apply nodal analysis. Okay, so when you apply the nodal analysis at node Vx. Okay, so what are the entering currents? No entering currents, all are leaving currents. Indirectly is nothing but application of KCL. Okay, so when you apply the KCL, you can see here I1 current is leaving, I2 current is also leaving, Ix current is also leaving. So therefore no entering currents, all are leaving currents, which is nothing but I1 plus I2 plus Ix. So that is equal to, how to write down I1. I1 I can write down it as a Vx. Okay, so leaving terminal is plus Vx, and next leaving terminal is minus. So Vx minus 30 divided by R. R value is how much? 1000 plus I2 value. So I2 is the current which flows in this branch. Okay, the current which flows in this branch. So this I can write down it as Vx minus 0 divided by 1000. Okay, and Ix. So Ix is the current which flows in this branch. So this Ix I can write down it as Vx minus 0 divided by 500. Okay, so here let's try to segregate the real terms and the magnitude. So when this 300 comes this side, which is nothing but 30 divided by 1000, and take Vx as a common term. When you take Vx as a common term, then you are going to get 1 by 1000 plus 1 by 1000 plus 1 by 500. Okay, so when you solve it using your calculator, then we are going to get the value of Vx is equal to 7.5 volts. Okay, just substitute this Vx in the above equation. Okay, therefore 0 is equal to 7.5 minus 30 divided by 1000 plus 7.5 divided by 1000 plus 7.5 divided by 500. Okay, so when you do it, then you're going to get this value as a minus 22.5 milliampere plus 7.5 milliampere plus 15 milliampere. If you add these two, that will be equal to 22.5. So where your KCL is verified. Okay, now let's try to do what to do here. Okay, so this is nothing but, you can see here, this is nothing but the value of I1, and this is the value of I2. Okay, so here we need to substitute these I1 values as well as I2 values. So just substitute here. So 30 divided by minus I2. Okay. So I2 is how much? So I2 I have been taken in this direction, which is nothing but 7.2. Minus also you can take, will be the same, which is nothing but 7.5 milliampere. So 30 divided by 7.5, we are going to get it as 4 kilo ohms. And I1 value is 22.5. So 22.5 milliamperes divided by I2. I2 value is how much? 7.5. You no need to bother about the polarity, just you can write down. So the polarity change, what I am considering is very simple. You no need to bother. So here I1 is the current which flows in this direction. So this I1 is how much? Minus 22.5. Whenever it flows in this direction, then it is 22.5. This is the direction of I1. So this is the direction which flows in this direction, and that's why I'm taking this as positive. When you solve it, you're going to get this as 22.5 divided by 7.5, you are going to get it as 3, and there is no units. Okay, so here you can see here, so successfully we obtained the values of ABCD parameters. Okay, so here we got A is equal to 3, C is equal to 2 millimos, and B is equal to 4 kilo ohm, and D is equal to 3. So half diagonal of this B will be in ohms, this will be in mhos. This is an reverse voltage gain, that's why no units. This is current again, that's why no units. So if you want to do the tabular column for this, also this is very simple. Let's try to draw the tabular column for this one. So for the tabular column, if you draw the tabular column for this, same, you're also going to get a table with first row as theoretical calculation and second row as a practical calculation. And what we had done here is V2 equal to 0. V2 is 0 means output port is short circuited. Okay, when V2 1 is 0, then you are going to get the another parameter which is nothing but the value of V1. Okay, we are going to get the value of V1, and next two parameters you are going to get it as one is I1 and next one is I2. Okay, so by solving the value of V1, we obtained, I mean already we are applying V1 is 30, and I1 we obtained as 22.5 milliampere, as well as I2 is equal to 7.5 milliampere. When you do the practical calculation also, you'll be getting this as 30 and 22 and 7. So just you'll get the same ABCD parameters if you do by practically also. Okay, so if you get doubt, very simple, the current flows in this direction. For example, current is flowing in this direction, then it is I1 is equal to 22.5. This is the original direction of the current. Why? Because source is here. If you do the nodal analysis like this, analysis is very simple. That's why I had done by taking which flows from high potential to low potential. But original is I1. So here I1 is 22.5. So when this is flowing from in this direction, this is positive. When it flows in opposite direction, this is minus 22.5. So both are same, but the direction of current is reversed. It's very simple to understand. If you solve more problems, you'll get more confident. Okay. Hope we successfully solve the problem and find the values of ABCD. If you feel my content is useful, please give a like to the video and share with your friends, those who are studying this subject. And if you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulasi. So kindly encourage these type of channels. Why? Because these are the free channel for the development of students and faculty. Thank you for watching. We'll meet in the another good video on one more problems. Thank you for watching. We'll meet in the